Hey Pre-Calc, how's it going? So we're going to pause on Chapter 6 for now. We may come back, but we're going to move on to Chapter 10. This is some stuff that you guys have at least seen before. So sequences and summations for today. Probably tomorrow. Here are some of the objectives we're going to be talking about. Finding particular terms in a sequence from a general term. Use recursive formulas. Use factorial notation. And the summation notation. Okay, the definition of a sequence. An infinite sequence, A sub n, is a function whose domain is the set of positive integers. The function values, or terms, of the sequence are represented by A sub 1, A sub 2, A sub 3, A sub 4, all the way to A sub n, and then continues on because infinite, goes on forever. Sequences whose domain consists of only the first n positive integers are called finite. So finite means that there is an end. Feel free to pause it to fill out these definitions. So here it says, write the first four terms of the sequence whose nth term or general term is given by. So this is a nth term formula. It allows us to figure out specific terms. So here we have A sub 1. So we do 2 times 1 plus 5. Well, 2 times 1 is 2 plus 5 gives me 7. Okay, my second term is A sub 2. So that gives me 2 times 2 plus 5. Well, 2 times 2 is 4 plus 5 is 9. Then we have A sub 3. So that's going to be 2 times 3. So that n value is the same one as right here. And then plus 5. So 2 times 3 is 6 plus 5 is 11. And then A sub 4 is 2 times 4 plus 5 equals, so that's 8 plus 5 is 13. So my first four terms we can write out as 7, 9, 11, and 13. So again, just notice that whatever your number you're trying to find is also what you're putting in there. So those two match. Example 2 is just like example 1. They want us to write out the first four terms of the given sequence. So we're going to do A sub 1 first. A sub 1 equals negative 1 to the 1 all over 2 to the first plus 1. Well, negative 1 to the 1 power is negative 1. 2 to the 1 power is 2 plus 1 is 3. So negative 1/3. Then we have A sub 2. That's going to be negative 1 squared all over 2 squared plus 1. Well, negative 1 times negative 1 is just 1. And then 2 squared is 4 plus 1 is 5. Okay. A sub 3 equals negative 1 to the third power all over 2 to the third plus 1. So negative 1 to the third power is negative 1 times negative 1 times negative 1, which is negative 1. So since it's odd, you know it's going to stay negative. And then in the denominator, you have 2 times 2 times 2, which is 8 plus 1, and that's 9. And then A sub 4. And this gives me negative 1 to the 4th over 2 to the 4 plus 1. So it's even, so that means negative 1 times negative 1 times negative 1 times negative 1 is just going to be a positive 1 because you're multiplying an even number of negatives. And then our bottom is 2 to the 4th. Well, 2 to the 3rd is 8 times 2 is 16 plus 1. So this is going to be 1 over 17. So our solution set here is going to be negative 1/3, 1/5, negative 1/9, and 1/17. We're going to write them in the exact order that they are because they're specific numbers in a sequence. So don't reorder them from smallest to largest. We need them like this. Okay, so number 3, example 3 on your page you see is a typo. That is actually the solutions to the problem above it, example 2. So that brings us to our try it yourself. Hopefully you guys take a second and try this, pause your video, see if you can do it on your own. But we will do it together right now. I'm going to try to write a little bit smaller since I wrote them all on the same page. So we have A1. So that's 3 times 1 plus 4. Well, 3 times 1 is 3 plus 4 is 7. A sub 2 is 3 times 2, which is 6, plus 4, which is going to give me 10. A sub 3 is going to be 3 times 3, which is 9, plus 4, which is 13. And then a sub 4 is 3 times 4 plus 4. So 3 times 4 is 12, plus 4 is 16. Okay, so we can write our first 4 terms as 7, 10, 13, and 16. Okay, now we're over here for the other try it yourself. We have a sub 1. So negative 1 the first over 3 to the 1 minus 1. Well, negative 1 to the first power, let it still be negative 1, over 3 to the first power is 3, minus 1 is 2. We have, I'm going to try to write this one smaller. I said I was going to, and then that one was really huge. 2, negative 1 squared over 3 squared minus 1. Well, negative 1 times negative 1 is a positive 1. 3 squared is 9, minus 1 is 8. Okay, a sub 3, it's going to give me negative 1 to the 3 over 3 to the third minus 1. Negative 1 times negative 1 times negative 1 is negative 1, because it's odd. And 3 to the third power is 27. Minus 1 is 26. Okay, a to the fourth. Negative 1 to the fourth power. 3 to the fourth minus 1. Okay, negative 1 times negative 1 times negative 1 times negative 1. That's even, so it's a positive 1. And then over here we have 3 to the fourth power. So 3 to the fourth power, so 27 times 3 is 81. 81 minus 1 is 80. I had to use my calculator on that last one. That's not one I naturally had memorized. If you guys did, way to go. No shame in using your calculator on this part, though. We want to make sure we get accurate answers. Okay. So even on the last one, I should have mentioned this sooner, but even with this one, I will. So with the ones where you see the negative 1 being raised to a power, we call these alternating series because it's going from positive to negative or negative to positive, and each term alternates signs. So we also have recursive formulas. A recursive formula defines the nth term of a sequence as a function of the previous term. So we need to know the one before it to be able to solve the current one. So again, you can pause it to write this down. Okay, so here, find the first 4 terms of a sequence in which a sub 1 is 3 and a sub n is 2a sub n minus 1 plus 5 when n is greater than or equal to 2. Well, we have to say that because you know what the first term is. A sub 1 is 3. It's given. So a sub 2 is going to be 2 times, and then that n minus 1 is just saying it's the previous term, so you're going to put in the 3 here, plus 5. Well, 2 times 3 is 6. 6 plus 5 is 11. And then we go on to a sub 3. Well, a sub 3 equals 2 times the previous term. Well, the previous term's answer was 11 plus 5. So 11 times 2 is 22 plus 5 is 27. A sub 4 is 2 times 27 plus 5. Let me grab out my calculator. 27 is 25. And then, just to be safe, 27 times 2, 54 plus 5 is 59. So my first 4 terms are 3, 11, 27, and 59. And again, you used this number here from the last one. Okay, so that's what makes it recursive. Now you have another try it yourself, so let's clear this board and we'll write that out. So this one says, find the first 4 terms of a sub 1 equaling 5, a sub n equaling 3an minus 1 plus 2. Okay, so you know your first term is a sub 1. It's given as 5. Your second term is a sub 2. So it's 3, our previous term, which is that 5 plus 2. So 3 times 5 is 15 plus 2 is 17. A sub 3 is 3 times your previous term, which is 17, plus 2. Okay. 3 times 17 is 51, plus 2 is 53. And a sub 4 is going to be 3 times 53 plus 2. 159 plus 2 . I just want to double check my math real quick. Okay, 53 times 3 is 159 plus 2. Okay, 161. Okay, so here we have 5, 17, 53, and 161. I think that's what we'll stop for today. We'll do day 1 of 10.1, and then tomorrow we'll pick up with factorials.